I had to come to school for this demo because it's got some dangerous stuff. Didn't want to get my family hurt. Zoe's helping me videotape. Thank you, Zoe. And I got this new lab coat, so I'm kind of liking it. Zoe's making fun of me, but hey, it's fun. All right, so today's lesson is about learning about electrolytes and strong electrolytes versus weak electrolytes. So Zoe, if you could help kind of zoom in with this board a little bit. So, and I'll do a little bit more of a lesson a little later on, but when we think strong electrolytes, they're gonna break apart completely. So hydrochloric acid, and I'm gonna show you on our reference sheet where you can find a list of strong electrolytes and weak ones. Hydrochloric is an example of a strong electrolyte. It's gonna completely break apart into its ions. It will not stay together as hydrogen chloride. Sodium hydroxide is another strong electrolyte. It completely breaks apart. Every molecule, shouldn't use the word molecule, so every ionic compound of this is going to completely dissociate into the sodiums and the hydroxides. And remember, these things is what makes something an electrolyte, okay? Now we're looking at acidic electrolytes and basic electrolytes, but like salt water is an electrolyte. Saline solution is an electrolyte. So whenever you think about Gatorade, one of their big selling features is it replenishes your electrolytes. Those of you that are in a human A&P type of class, you understand that because you've gotten used to the sodium-potassium pump and how that helps with our cells and with respiration. So electrolytes are a good thing. Kind of a cool characteristic of electrolytes, whether they're strong or weak, is they'll also conduct electricity. So we're going to do something with that here in a second. So strong ones, they're going to look a little different with conducting electricity compared to weak ones. These will break apart completely. Now if we look over here, Zoe, if you could help out. Those things that are weak electrolytes dissociate partially. So they'll still break apart, but they're gonna break apart partially. So what does that mean? Acetic acid is an example of that. And vinegar really is our solution that we find in our house of acetic acid. Ammonia is an example of this. So these are still gonna break apart. Now Zoe, I'm gonna stress you out a little bit. Look at this equation and specifically look at the arrows. What's the difference between these arrows and those arrows over there?
You're asking me.
I'm asking you. And I don't want to freak you out. Don't like, your mom got lazy. It really could.
They're pointing both directions.
Yes. Over here they're pointing both directions. Over there?
One.
They're only pointing one direction. Okay, good job, Zoe. So you are ready for TC chemistry. So over here they're pointing both directions because it's trying to signify some of it's going to break apart into an ion, but a lot of it stays stuck together as that molecule. Another kind of weird thing, I specifically picked ammonia. Ammonia is a really strange base. I think Miss Merkus maybe talked about it in yesterday's lesson. But what ammonia does is it actually reacts with water, and that's where we get these ammonium ions. And right here is what makes ammonia basic. There's my hydroxide ions that I get. So they're still going to dissociate, but they're going to dissociate partially. We're going to see that impact here in a second. So you might have to scoop back out a little bit. I don't know, maybe not. But we're going to start with, and I might just actually start with some of the weak ones. So we said that ammonia, NH3, that's what this is right here. So mom might use this. Sometimes you add it into laundry. You can use it as a cleaning agent. This is the active ingredient in Windex. You want to make Windex at home? You use a little bit of ammonia. You make it an aqueous solution. You guys know how to do solutions now. It's a volume, ammonia and water, and then they just add a little bit of blue coloring to it. So I'm going to take this light bulb, this is something you're used to, and are you catching? The light bulb lights up, but it would be really sad if I decorate my Christmas tree with light bulbs that do that type of thing. So ammonia, a weak electrolyte, it's going to partially dissociate, not completely. Now we said acetic acid is also a weak one, right? So I would expect that same type of thing here. It's not even going on. Like that's how weak it is. Okay, so I've got to take something that needs even less power. Zoe, you're definitely going to have to zoom for this. You might have to, there you go, you're doing great. So I'm going to take, and I can't remember if we used this in this class or not, but this is a conductivity tester, and these two little light bulbs, if they conduct, will light up. So it does work, but barely. Okay, so a weak one, again, it does work, but barely. Okay, let's do this same idea. So these two were weak. Do they conduct electricity? Yes. Like I don't want to conduct electricity, put my finger in there and see what happens. But they're not going to be, according to this concept, they're not going to conduct as good as my strong bases and my strong acid. So this is hydrochloric acid, 0.5 molar, so it's not really concentrated. We buy it as 12 molar, so this is very, very diluted compared to what we buy. And let's see what happens here. Okay, big difference. Sodium hydroxide, this is 1 molar. Sodium hydroxide we actually buy as a solid, so that would be like a mass volume solution. And again, strong electrolyte. Okay, let's go back to the one that is at least strong enough to light up this light bulb. It allows 120 volts to go through. We see it do something, so the ammonia still does something. Now, acetic acid, again, go back here, not even strong enough to light this guy up of 120 volts, but if I try to use 9 volts and I really reduce the amps going through, I can see that light up. Okay, electrolytes. Strong ones totally break apart. Weak ones still break apart, but not completely. See you guys later. Bye.